Our focus for this video is the cosine rule, right? Now the cosine rule is applied to a non-right angle triangle. Now on the board here, I have a non-right angle triangle, which is ABC, right? So let's say that I want to label the sides of this triangle. Normally, if you have A here at this vertex, the side that is opposite to this angle here gets the lowercase letter, right? So, or another way to look at it, angle A creates the line BC. So that means this line here is common A, right? Use the same idea. Angle B creates the line AC. So this line here is common B here. Angle C creates the line AB. Therefore, AB is common C, right? But let's say that you're curious and you want to know the altitude of this triangle, and you draw a line, straight line from the vertex of B that is perpendicular to the line AC, right? Which means that now you create a two right angle triangle within this non-right angle triangle. Now you call this point here H, right? So this is the altitude, and you call the altitude H, right? So now we have two right angle triangle, one of them, and at this point where the altitude meet this line, you call it D. So let's say you call it capital D, right? Let me just write this D down here. Right? So now, what you want to do, since we are talking about cosine, you want to take the cosine of A here. Right? So you want to take the cosine of A, which is this angle, here. How do you think you would go about taking the cosine of A? Now first, you would have to, there's two triangles. Well, actually, technically it is three triangles, but you have two right angle triangles, right? Which is ABD and BDC. So you would have to consider the triangle ABD. So, focusing on triangle, and this symbol means triangle, triangle ABD, we can take the cosine of A, right? So cos A is equal to the adjacent side, right, over the opposite side. But for this triangle, we don't have a measurement for the adjacent side. So let's say that the distance from A here, from point A to B, that distance is X, right? What do you think the distance from D to C would be? From B to C. If the distance from A to D is X, it means that, and the distance from A to C is B, it means that the distance from D to C has to be B minus X. So now that we have all the information, we can go ahead and find cos A. Cos A is the adjacent over the hypotenuse. What's the adjacent length in this case? That's just X. So this is just X over the hypotenuse, which is C in this case. Right? But what does this imply? This implies that X here is actually equal to, let me write it down here. So this implies that X here is actually equal to C cos of A. How did I get C cos of A? All you need to do, if you want to make X the subject of the formula, you multiply both sides by C. and x is equal to c cos A, right? But could we actually apply the Pythagorean theory to the triangle ABD? Yes. Do we have all the length, right? So the Pythagorean theory states that the square of the hypotenuse is equal to the sum of the square of the other two shortest side, right? So that means we could apply Pythagoras to this triangle as well. So let's see. If we apply Pythagoras to this triangle, we're therefore saying that c squared is equal to x squared here, x squared plus 8 squared. 8 squared. Alright? Let's move over to the other right angle triangle, which is BDC. So now we are focusing on triangle. I'm focusing on triangle BDC. And we want to apply the Pythagorean theory to this triangle here. Clearly, where A is, that's the hypotenuse, right? And this, that's the hypotenuse, and we have the length for the other two shortest side. That means we can apply the Pythagoras theory to this triangle. So we can say that A squared is equal to b minus x all squared plus 8 squared. Clear there? Alright? Now, how can these information help? Here, if I apply the Pythagorean theory, I have c squared is equal to x squared plus 8 squared. And here I have an 8 squared in this formula. That means I can use one of the formula to make h squared the subject of the formula, right? So I'm going to transpose this one to see what h squared would equal to. If I want to find what h squared is equal to, all I need to do here is to subtract x squared from both sides. So if I subtract 8x squared from both sides, on this side I'm going to have c squared minus x squared is equal to 8 squared. So now I know what 8 squared is. So I can substitute this value for 8 squared in this equation here, right? So if I substitute what 8 squared is in this equation, I am now going to have a squared is equal to b minus x all squared plus 8 squared. But what is 8 squared here? I am going to substitute c squared minus x squared is just 8 squared. So this is c squared minus x squared in bracket, right? So now I have a squared is equal to b minus x all squared plus c squared minus x squared. So what I'm going to do is to try to simplify this, right? Now, b minus x all squared means b minus x times b minus x, right? So you can use your file method to multiply this. So a squared is equal to, here the first term is going to be b squared. So this is going to be b squared. Here I have b times a minus x, and it's going to be two of them. So this is going to be minus 2bx, right? And then you're going to have plus x squared. So when you expand this, that's what you're going to have here. Plus this c squared minus this x squared. Right? Now, note here, what I have is a x squared, a positive x squared, and a negative x squared. So it means that these two things can cancel out. So this positive x squared going to cancel out this negative x squared. Right? So all I'm left back with is a squared is equal to b squared. And since this term is a plus c squared, I'm going to put it beside this b squared. So this is becomes plus c squared minus all of this term, which is minus 2bx. Right? Here I have a x here. But what is x? Over here we know that x is equal to c cos a. So I can replace this x here with c cos a. So therefore a squared is equal to b squared plus c squared minus 2b. Instead of writing back x here, I'm going to replace it with the value of x, and x is c cos a. So this is a c cos of a. What is this? This here is the cosine rule. So a squared is equal to b squared plus c squared minus 2bc cos a. That is the cosine rule. So this is one version of the cosine rule. Okay, so now we know that the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos of a, right? And that's one version of the cosine rule. And this rule is used when you are calculating the length of a. But what if you want to calculate the length of b? I'm not going to show you the proof for this, but basically b squared is equal to a squared plus c squared minus 2ac cos of the angle here, which is cos of b. And if you want to find c squared, then c squared is equal to a squared plus b squared minus 2ab, right, cos of the angle here, which is cos of c, right? So this version of it is used to calculate the length of a missing side. But what about when you want to calculate an angle here? Such as cos A. How would you use this formula to calculate cos A, right? Now, cos A is equal to, cos A is basically equal to b squared plus c squared minus a squared. So it's going to be b squared plus c squared minus a squared, all of that divided by 2bc. So divided by 2bc. Alright? That's it. What do you think it's going to be for cos b? Cos b is equal to, here, still going to be a squared plus b squared minus b squared here. So it's going to be a squared plus c squared minus b squared all over 2ac. And for cos c, cos of c, that's going to equal to a squared plus b squared minus c squared, all of that divided by 2ab. Now, these are the formulas that you will use depending on what the question asks you for. So now we are going to use the cosine rule to find the length of A, right? So we know if we take the square of A squared is equal to the square of this side, which is 4 squared, plus the square of this side, which is 5 squared, minus 2 times this side, which is 4, times this side, which is 5, times the cos of this angle, which is 60 degrees. Now all you need to do is to simplify this. So a squared is equal to 4 squared, which is 16, plus 5 squared is 25, minus 4 times 5, that's 20, times 2, that's just 40. So this is 40 times cos 60, but cos 60 is just a half. So this is times a half. All of this in bracket there. So now a squared is equal to 16 plus 25. 5 plus 6, and that is 11. So this is 1. Carry 1. 2 plus 1, that's 3, plus 1 more, that's 4. So this is 41, minus 40 times a half, that's just 20. Alright. Now we end up with a squared is equal to 41 minus 20, that's 21. Now we have a squared, but we want the length of a. So what you're going to do is to write back what you have, which is a squared equal 21. And you're going to take the square root of both sides because we want to get rid of this square here. So you take the square root of this side and you take the square root of this side. This square root sign cancels out this square. Leave us back with a is equal to the square root of 21. And the square root of 21, you can put that on the calculator. That's approximately 4.6. And our unit is meter. Meter. And in bracket you put correct. 2 SIF, 2 significant figures. Right? And that is how you would use the cosine rule to find the length of a given side of a triangle. Let's look at the second one. Now, the second one, again, note that the cosine rule is only applied to non-right angle triangle. Is this triangle non-right angle? Yes. It is also used when you are given two lengths and an angle between them. Do we have two lengths and an angle between them? Yes. So that means we can apply the cosine rule to this question. So, x squared is equal to this side squared, which is 7 squared, plus this side squared, which is 8 squared, right, minus 2 times this side, which is 7, multiplied by this side, which is 8, times cos of the angle, which is cos of 70 degrees. So x squared is equal to 7 squared, means 7 times 7. 7 times 7 gives us 49, plus 8 squared, which is 8 times 8, and that's 64, minus 2 times 7 times 8, and 2 times 7 is 14, and 14 times 8, that is 112, times cos of 70 degrees. Right? Now, x squared is equal to 49 plus 64. So 4 plus 9, that's 13. That is 3. Carry 1. 6 plus 4, that's 10. Plus 1 more, that's 11. So that's 113 minus 112 times cos 70. But you can put that on your calculator. So that's 112 times cos 70 degrees and that is equal to approximately 38.3. Now x squared is equal to 113 minus 38.3, and that gives you approximately 74.7. Now you need to find what x is and not what x squared is, so you need to take the square root of both sides to get rid of the square. So take the square root of this side and you take the square root of this side. This square root cancels out the 2, so x is left equal to the square root of 74. Place that on your calculator. The square root of 74.7 equal, that is approximately 8.6, correct, to 2 SIF. And SIF means significant figure. So that is how you would use the cosine rule to find this side. We are given the length of 3 sides, which is 5 meter, 4 meter, 3 meter. We are given an angle, and we are asked to use the cosine rule to find this. So now we want to find an angle. We can therefore say that cos of this angle, which is P, is equal to this side squared, which is 5 squared, plus this side squared, which is 3 squared, subtract the side that is directly in front of the angle here, that is opposite to the angle, which is where 4 is. So subtract 4 squared all over 2 multiplied by this length, which is 5, times this length, which is 3. You can put that on a calculator in one go, but cos P is equal to 5 squared, that's 25, plus 3 squared, that's 9, minus 4 squared, that's 16. All of that divided by 2 times 15, 2 times 5, sorry, that's 10, times 3, that's just 30. Which is equal to cos P is equal to 25 plus 9, that gives us 34, minus 16 all over 30. So cos P is equal to 34 minus 16, and that is 18 over 30. Right? Now at this stage you want to find P. What you need to do is to take the cos inverse of both sides. So P, in this case, which is degrees, P degrees is equal to cos inverse of 18 all over 30. And you just put that on your calculator and you're finished. So you press shift, cos inverse, select your fraction bar, and that's 18 all over 30. Close your bracket, press equal, and that gives you an angle of P degrees, which is equal to approximately 53.1 degrees. Correct, to 3 SF, significant figures. Alright, so that is how you would use the cos rule to calculate an unknown angle. So let's look at our final example. Our final example again, we are given the length of 3 sides, and an angle which is x degrees here. So we can say cos of x degrees is equal to the square of the two sides that the angle is between. So it's going to be 10 squared. So it's going to be 10 squared plus 9 squared, subtract the side that is the square of the side that is opposite to the angle, which is this side here. So you're going to subtract 6 squared all over 2 times the length of the sides that the angle is between, times 10 times 9, right? So cos of x degrees is equal to 10 squared, which is 100, plus 9 squared, which is 81, minus 6 squared, which is 36. All of that over 2 times 10, which is 20, times 9, which is just 180. Right? Now you can put all of this side on your calculator here. And I'm going to show you. So cos of x degrees is equal to all of this side. So you can just put that on your calculator. Select your fraction bar, and that's just 100 plus 81 minus 36. All of that over the denominator of 180. Press equal, and that gives us 29 over 36. Now you want to find what x degree is. So what you need to do is to take the inverse, the cos inverse of both sides. You take the cos inverse of this side. X degrees is equal to cos inverse of 29 all over 36. So x is degrees is equal to, put this on your calculator. Final answer is 36.3 degrees, correct to 3 feet SIF, right? And that is how you would use the cosine rule to find a missing angle. Thank you for watching, and do enjoy the rest of your day.